Hi, and welcome to the part 2 of the wonderful world of graphs. Hopefully you've already checked out part 1 where we introduced graphs, a couple of different types of graphs, how to interpret data on a line graph. And here we're going to take the next step and look at the basic requirements for a good graph. So we've already discussed a couple of things. We've already looked at the types of graphs that you could use and interpreting what the graph is telling the reader. Here we're going to focus on the basic requirements for a good graph and then how to construct graph from data that has been collected. So our focus is going to be on line graphs for the time being, and remember that line graphs are appropriate to be used when data collected is referring to a continuous process. And a lot of the time, and a lot of your experience is going to be with processes that occur over time. And when those processes are continuous over time, any of the data points that we collect can appropriately be connected by a solid line. We will again revisit that determination that needs to be made for different collections of data, but for now we're going to look at continuous processes and construct a line graph. So let's check out some of the basic requirements for a good graph. And the procedure that we're going to talk about applies primarily to graphs of experimental data from experiments that are going to be presented for critical evaluation. Critical evaluation. Oh, in other words, they might be turned in. They might represent work that you do in the lab. It doesn't necessarily apply to rough sketches that you might have in your lab notebook, just for the purpose of illustrating what's going on, for your own use, or sometimes even for predicting what you think might occur in a lab. But it starts with a title, and we need a good title. Not just a title, we've got to have a good title. And before we can even look at a title or make a good title, we have to have an idea of trying to decide what would be useful. We got to figure out what the data is trying to tell us. So in this example, okay, we're looking at slices of pizza remaining over a bunch of time at a party. Now, if you like pizza, it might be useful to know when the party is being held. Otherwise, without it, you might just think, oh, this applies to any gathering where pizza is served. So here we've got some examples. We've got 3 examples of short titles. And let's be clear, we said good titles, right? Those might be entertaining. You might think they're kind of humorous, or not. But a humorous or just a cute little title's not good enough for what you will need to convey. So let's check out this title. Figure 1, anticipated consumption of slices of pizza at the AP Biology Party, March 9, 2011, from 7 to 9 p.m. There's no question what that line or what the visual here in this graph is telling us about the data. Now, some of that might be a little over the top for our purposes, but there's no question what this data is telling us. And the real point here that we're driving home is that it's a good title that we need. And a good title is one that tells us exactly what information the author's trying to present with this graph. So brevity is desired, getting to the point is desired, but I want to be very clear. That's no substitute for completeness and clarity of your title. Notice that this title is darn near a complete sentence, and that is just fine. So taking a look at these two graphs, the one on the left really tells us nothing. All it tells us is that some process, and maybe it's a continuous process since we have data points that are connected by a solid line. Unfortunately, we can't tell anything. It has no labels, no numbers, no units on any of the scales. So even though this may be descriptive of a process, it's no use to us without some very important parts. So before we can take full advantage of the information the graph is trying to tell us, we got to have some additional details. The one on the right now, and I noticed, of course, I didn't put a title in here, I should have, but at least now we know with the figure on the right that we're looking at scores on an exam in relation to the amount of time put in studying in hours. And so we've got some additional information. We're still not there yet. It doesn't tell us enough. So here we've got the basic requirements of any graph that we use. We already discussed the importance of the title. We will discuss further, down the line we'll discuss the description. Really the description just goes a little bit further than our already very detailed title. Actually, to be clear, if you check out any scientific literature or publication, or in other words, if you just look at a science textbook, you'll see like figure 1 with a good title, but it'll go on to maybe provide a sentence or two in complete description of what the experiment was, what the data collection involved, and what the actual researcher did. Not a complete dissertation describing the methods of the experiment, but a great description to give the reader more information about what the data is telling us. Take a look at the axes. We've got the y-axis and the x-axis, and they are both labeled. Just labeling them with a name, however, is not enough. In fact, for example, on an AP biology exam, if you were to put a graph as a requirement for part of your free response and you leave out units, you leave out your chance to score points. So you've got to have labels including the units. You've got to have numbers along each axis to give you information about the scale, and you also need to have index marks. Now, here's some good news. You will often use a digital platform to create a graph, whether it's on the iPad or on a computer. And good news, a lot of times that is done for you. The scale and the index marks is done for you, but you will always have to purposefully put the units and the labels with us. You can also have, this is called the frame, just makes it look a little bit better by framing in the grid. So having just looked at the basic requirements of any good graph, including the title and description, let's look at labeling the axes. Now this is really important. We need to have the appropriate variables on the appropriate axis. And we will discuss the dependent and independent variables over and over. You'll be quite familiar with them. Almost always, for our purposes, the dependent variable is appropriately placed on the y-axis and the independent variable is on the x-axis. The dependent variable is that variable or that set of data that the researcher is going to collect. It's the factor that is measured or recorded as a result of the experiment as it proceeds. So it's the factor that responds to changes in the independent variable. Now there may be exceptions to that, and we'll revisit those down the road. The independent variable is that variable that the researcher sets up or that the researcher is seeking to explore. So we can look at a way to try and keep this straight. The appropriate acronym that I like to use here is dry mix. So those letters stand for dependent, responding, y-axis, and the manipulated, independent, on the x-axis. So if you go back and look at the axes that we just had in the previous slide here, the dependent or the responding variable should appropriately be placed on the y-axis. It's that data that responds to whatever conditions the researcher sets up and places on the x-axis. I can't really say this enough, however. This is a common mistake in science and in society, again, in the media, in social media, newspapers, etc. Authors often overlook this, and the reader, and you will get very good at this, the reader must keep in mind that the independent variable does not always cause the change in the dependent variable. Now that's a whole nother conversation. Causation versus correlation is a very tricky little dance that readers of graphs need to do. Just remember that they don't always affect one another. But keep dry mix in mind, and that will help us, for our purposes, place the correct data on the correct axis. So again, graphs are super important. You need to know how to not only construct them properly, but even more, I would say, is a life skill, is to be able to be critical of graphs that you see and be able to interpret what the author is trying to tell you. And you also need to interpret if that story is trying to manipulate you or if it is certainly just trying to convey data. Thanks for watching.